Hard to perform.
And our feet are shown.
So I haven't seen JJ in ages. JJ's still around.
He is. Oh, sorry. Wow. That was unintentional. He only comes in on Fridays. Yeah, he only comes in on Fridays. You know what? That'll be a better place for you.
All right, let me get everybody. Good morning. If we can all get in your seats, please. Wow, I didn't know I had that big a voice. Yeah. Good morning and welcome to Montgomery County Community College's Enhancing the Educational Environment, the 22nd Annual Technology and Learning Conference. Thank you for being with us today. My name is Mary Kate Najarian and I'm your conference chair. I want to take a moment to thank the committee, the Monco IT and IR department, and all the other departments that helped make today possible. The conference has 38 sessions, 18 vendors, a keynote panel, and a virtual campus or virtual option. The conference would not be possible without these people. It takes a lot of man hours to make this happen. Please help us by filling out the conference evaluation, which you found when you got your packet. This helps us evaluate the conference and determine what happens next year. Our social media hashtag for this event is hashtag MC3TechDay. Please tweet, share pictures, spread the wealth of knowledge. Please visit our vendor sessions on the first and second floor of the ATC building, who help make this conference possible as well. So, who wants to win prizes today? All right, there's 3 ways to win prizes. Can you tell me which 3 you might win prizes for? Okay, in the back of your ID, there's a ticket. If you tweet, we'll count how many tweets are out there. And the last is we're going to randomly pick somebody's ID and give you a prize. So, how do I know I won a prize? On the first floor, we're going to have that information on a board for you to win, and just keep going back throughout the day to look. Ready to get the conference started? It's my pleasure to introduce Dr. Celeste Swartz, Montgomery County Community College's Vice President of Information Technology and Chief Information Officer. She is responsible for academic and administrative technology and technology supporting process improvements. In addition to her technology focus, Dr. Celeste Swartz provides leadership support for the college's sustainability, student success initiatives, and overseeing the institutional research department. Dr. Celeste Swartz.
Good morning to my Montgomery County Community College colleagues and to my special friends from our neighboring K through 12 institutions as well as colleges and universities. Welcome this morning. I hope you have a great day. So at this time, it's my pleasure to introduce the keynote speaker who will kick off the panel discussion, Brian Knotts. Brian is currently the Vice President and Chief Scientist for Ellucian and has been with them for the last 20 years. Brian and his team are researching cloud technologies focusing on microservice-based architecture using native cloud services and creating security solutions for Ellucian products. Currently, Brian is exploring the world of the Internet of Things, virtual reality, and machine learning. I want to welcome Brian to the podium.
Thank you. Okay. Some water here. And let me fix this mic. Okay. So today what I wanted to talk to you a little bit about, this is still a little low, is sort of how the technology is going to change for the applications we're using, mostly in administrative computing. And then we're also going to have a panel discussion about how we're changing education at the same time using technology. What is going to be different about how we can educate our students? So today, if you look at what we largely have been through and how we've used computers, that's a Babbage machine. We've done a lot of computing, you know, a lot of calculating, adding and subtracting. We also did a lot of scientific computing, right? If you think about things like, you know, airplane wings and, you know, calculating different things, computers have been very good at that. And then over time, after some of that happened, we came up with, obviously, computer servers, and then built these very traditional, these are current, but very traditional transaction systems. So in this case, we're using computers to keep track of information, keep track of your birth date and your address and your phone number. But it's pretty boring. I mean, it's pretty standard to just be able to do that. So my talk today, oh, and also data warehouse, right, came about, and there's a lot of other things there, but we're generally just using computers to either compute or keep track of information. And what I wanted to talk to you about today is what can we do with these things as a full next generation, making computers and the things that computers do a full partner a full backpack, if you will, that you can wear around and assist and change the way you're able to do things. So at the same time that we've had these computers that we come to work with, at home, we've had access to different kinds of applications. And I'm talking about social applications, I'm talking about the applications on your cell phone and so forth. And so what I see, or actually what the industry sees, is a convergence of some of this technology with these transactional systems. It'll still always be important to keep track of information in an institution or a business or whatever, but what is going to change and make these applications really unite with some of the applications that we have off to the side of traditional IT systems? So there's an acronym out there called SMAC. It's kind of a, in-your-face sort of name, but it really is it is really this new generation of applications that combine these different pieces. And I've got some examples that I'm going to go through. So again, there are a lot of courses, for example, and even a lot of groups in commercial companies or whatever will have Facebook pages. They'll use Twitter and all that sort of stuff. But it's not completely integrated, right? So what I'm talking about are applications that are completely integrated with the social aspect. As a matter of fact, there's an application out there that it's an HR system, a traditional human resources system. And on that system, anybody that's an employee of that institution can create a poll or comment, as part of the innate part of the application itself. It's not like a separate thing that they set up. Another trend, obviously, is mobile. And we still haven't crossed that boundary where our applications, our IT applications, are truly mobile. That's just emerging now with responsive design, but they weren't necessarily mobile first. They weren't designed to be mobile. A lot of what we're doing is pushing applications that are traditionally on the web, or even maybe bare metal type applications and making them, mobile enabled. But they're not built the same way that the applications on your phone that are native are built. The other thing, and Dr. Swartz is going to get into this a little bit, is she's going to talk about analytics, but what I would offer is, in some cases, even those analytics that are very exciting that she's going to talk about are not deeply integrated directly in the application. There's something we go to, there's something we use, but they're not an innate part. And this SMAC application architecture says those analytics are actually playing an active role in the application itself. And then finally, the cloud. And the cloud allows this massive aggregation of data to become available to everyone, because not this institution or any other institution has all the data to really make great insight. So the cloud allows some of these applications, and the example I'm going to show just on the next slide will be a good indication, because you can't get much more remote than what this particular application space is. So what I'm talking about here is just how do we get all of this stuff really together and create a new generation of applications where the transactions, in some ways, keeping track of data, are pretty much off to the side, and it's really this more social type of atmosphere. So a very unusual thing is going on in agriculture, and farming is actually older than education by quite a bit. Farming goes back, according to National Geographic, I found some stuff on that, around 12 to 14,000 years ago. So farmers have been in business far longer than educators. You also, I think, traditionally think of agriculture as probably something that's been pretty, static and not very much of the information age. But these guys are really technically savvy, this whole business. And I had 4 or 5 slides that I wanted to show you. This slide, the first slide here, shows you device that they can add to the equipment that'll actually steer the tractor, so that the farmer is actually able to look at the data and be able to socially engage with other farmers and stuff, and it'll drive the tractor directly in a perfect line. And the slide, or the picture to the right, shows this is actually an animated slide, but I didn't bring the animation piece in it, where it's actually steering the tractor very precisely across the field. This picture shows, and it doesn't look like this on the farm, but what it's really showing is the different fertilizers precisely needed for each part of the ground there. So those colors represent different combinations of fertilizer that's going down. And this is all being done through this SMAC application, because it's using data that comes off the sensors and mixing the fertilizers and so forth right off the back of the tractor. And I'll show you what the yields are there. They're pretty dramatic. But had you ever really thought that farmers would have this type of sophisticated equipment? And this data is all going up to the cloud. If this just is a diagram that shows sort of some of the different things that are going on. The sensor box is right off the back of the tractor, etc., and it's kind of blown up there. But even the fertilizer is going down in the row, but not off to where the seeds are. So don't want to become, I'm not trying to teach you the entire thing, but just understand this precision architecture, or agriculture, is really significant, because if you put fertilizer right where the seeds are and not where they are, obviously you're saving money, because you're not putting fertilizer where you don't need it. This is what the cockpit looks like. I took one picture of that, and you can see that it looks, I originally entitled this slide, I said something like, is this an airplane or a tractor? Because it just has all this different equipment in it. So here's some statistics, and I think the key thing here is reduced input costs are 15%, and yield is up 13%. So if you add those two numbers together, that's 28%. That's a significant amount of increased profit and yield here. And I think everybody does know that we do need food to eat to survive at the end of the day. So this is these technologies out here in some of these areas that I was very surprised there was this much going on. But one last thing, they also, the folks that make the big data, so this data that comes off these tractors is all going up to the cloud. And without the cloud, there wouldn't be a way to do this, because no individual company could do this. So this data, in this case, is all from Farm Mobile, is all being aggregated in Amazon Web Services. And it's a win-win for the farmers, because they actually get paid to give their data. And then, of course, their seed companies and other folks pay to access the data as well. And then the farmer gets this data back, which figures into how this precision agriculture fertilizes the ground. So it's really a win-win. How many people use Waze? So Waze is actually one of these applications that qualify for what I'm talking about, kind of in a new generation application. It's got social built into it, because you're essentially telling it when you're in heavy traffic. If you're in heavy traffic, it says, are you in heavy traffic? Because I don't expect you to be. And if you say yes, that data is instantly or close to instantly being tested and looked at and pumped back out, and people are being rerouted. If there's enough of that heavy traffic, it'll reroute the next group of people behind you off the road. So it's actively taking data. And even if you're not on a direct trip, it's always aggregating that data. As a matter of fact, I just have some facts about what it's doing on the next slide. So it shares the real-time information, obviously, on traffic and road conditions. And those of you that paid for subscriptions, there's no cost if you've had a GPS, and they've never really worked that well as far as I'm concerned. I have a GPS in my car, like many of you probably do. I don't even turn it on. It doesn't even work 10% as well as Waze does. From all of the input that we're giving it, it can check for blocked roads, police activity, etc. They analyze this information immediately. So again, think of the social aspect of this. It's a mobile application. It's using analytics to direct you, not all just vectoring, but analytics to direct you where you're going. It also allows you, I've never done this, and I know my wife has, but you can correct the maps. This is kind of unheard of, where you let the crowd actually make your application better by allowing you to edit the navigation and stuff. Okay. And you can also interact, obviously. My wife and I interact. When my wife leaves work, she says, I'm leaving, and I see it on there and stuff. So it's fun. And it also has a point aspect to it, because we're all sort of gamers, right? So it has this ability to, it gives you points when you do things. It's kind of fun, but it also is a very effective application. Cars. I think we've all were told for some time cars have some 100 computers or whatever in there. But the most recent stuff that's been going on with these cars is, one article I picked up showed that Mercedes, BMW, and Audi are sharing the data. And this surprised me, because I thought, wait a minute, these are individual companies, they're competitive. But this article in Forbes was really saying that they're starting to share this data, and they're sharing data from all of these sensors, not just road data, but they're sharing video data and all sorts of things that are coming off the cars to make their systems in their cars better, although I don't think they'll ever catch Waze. So the other thing that's really been great is just the compute that you need to do these kinds of things, even any of the things that I'm talking about, and to be able to get that kind of compute. And so this is a little note from Quora that shows you how much more powerful the computers are. So if you look at some of those statistics, you can see that things like the instructions per second are 80.8 million times faster than the Apollo spacecraft. So this takes it, one of the things that was the perfect storm here is to have enough compute to do all this. And that has to increase as we go along. The last example I have, I don't know if you folks have heard of Lex Machina. This is a legal system that's out there that is actually, they've ingested all of the court cases and all of the different motions and everything. This application has read, they've ingested all of this data, and so they can actually, when you come in to have a case or whatever, they can tell you, look, Judge Brian is not going to rule in your favor. He 81% of the time in your situation, he does not rule in your favor. If we get an outcome from Judge Brian, it's going to be 8 months, 10 days, 14 hours or whatever. So this is very precise information that we're using computers to be able to do. So this is done by a paralegal, it's done by lawyers. It's why we all see these big case of leather books where they look at the different cases. Well, most of this data now is inside of this application and can very quickly, on a dime, tell you what the situation is. So this is the type of application that will be used across many different areas. And we think that in the applications that I work on student administrative systems, student learning management systems, We think that if we can bring this kind of data to students, think about the Lex Machina in the context of a student switching their major or contemplating a second degree, to be able to see how successful they are, rather than, the advising will still be a super important component, but just putting information like this Lex Machina does for legal into students' hands, it really is fascinating. But in the end of the day, when we do all this complex stuff that I just talked about, we really still have to make this leap, where we have to go from the left-hand side of the screen, the very complicated systems that we have, to the right-hand side, where we have a very simple access to this. And that's what makes all of these systems that I described, they have to be very simple at the same time. So complex in the background, but simple in the foreground. And with that, I think we're going to go into our panel discussion. Okay? So what I'd like to do is bring in our panel. We're going to have 3 panel discussions. We're going to start with Dr. Celeste Swartz. So her question is, what are some of the key things we're doing at Montgomery County Community College's IT infrastructure? Dr. Swartz?
Just a tad bit shorter, so. First I want to say, I just want you to think about where you might have been 15 years ago. And think about the technologies that you might have used and how different things are today. The presentation today, the presenters behind me are going to talk about things that this college is using today that didn't exist 15 years ago. They're also going to talk about a little bit about the future and the things that are on the horizon. I'm going to talk about the uncool stuff, the behind the scenes, the things we take for granted. What I call it is the light switch. So first I'll talk probably about the only cool thing that I think that I'm working on right now, which has to do with data and analytics, but you really have to love data. And let me say this, that the world in higher education is changing in a big way. We're being tested constantly with the question, and to what value is higher education? How can you prove that there's value? So first I want to say, from a data and analytics standpoint, we're really talking about support. So how can the data support the decisions the institution is making? How can the data validate student learning? All of those things are occurring at the college. We're dealing with trends. We're looking at our at-risk students. We're doing predictive modeling to try to determine what learning techniques or what services we might that might help students with their progress and success. So the other topic, I'm going to switch gears 3 times here. The other topic is really about the stuff, the technology infrastructure itself. So to be able to be here in this room, there are people with their iPads out, their iPhones out. You're all connected. You're either connected through cell phone service or cell phone tower service, or you're connected through our wireless infrastructure. That wireless infrastructure at our college gets updated about every 2 years, because our students are constantly bringing more and more devices, are downloading more and more items from the cloud while they're on campus. And the expectation is what? The expectation is instant, not 2 seconds, 3 seconds, or 5 seconds. That is all unacceptable. It's instant. And by the way, all of us who are sitting in these chairs, that's our expectation too. And when that expectation does not occur, Our phones ring off the hooks in IT because the expectation is instant. We've got virtualization. What does that mean? Once again, it's the stuff behind the scenes. Basically, what it means is that we have reduced the size of our infrastructure itself, the support models, with very, very solid, high-speed technologies. We're also moving to the cloud. Brian talked about that earlier. We have many of our systems, not our biggest systems like a Colleague or our learning management system, Blackboard, but most of our smaller systems that we're running are running in the cloud. And what does that mean? Brian talked a lot about the cloud. Some people in the audience may understand that, others may not. It really is just a big data center that exists somewhere else, not really in the cloud, but exists somewhere else. And that data center is a place where, one, lots of storage can, lots of data can be stored, and two, from a security standpoint, there is a lot more security that can be put around a massive data environment than when you have all these little individual organizations having their own data centers. So finally, what is all this about? And what is this day about? And what will you hear more about today? It really all boils down in education, whether you're in the K through 12 world or the higher ed world, into meeting the needs of the students. So from a IT standpoint, it really is about investing. This is what we're doing today. So I talked a little bit about as I termed utilities, right? Just like electric, heat, all the background of IT is happening and you don't even know what's going on or understand the complexities, which is a good thing. But really, what's the important investment in IT? The important investment really is about connecting the services to the student, connecting the faculty with the student, providing really solid tools that encourage engagement and also encourage communication and collaboration. Thank you.
Okay, so on with our panel discussion. Fix this for our next speaker as well. So, the question is going to be, how can the practice of education completely change the approach to accommodating students owning their own destiny? Now, the next two panelists are really going to stretch your thought of what traditional education is. And it's a very, to me, just hearing the backdrop and helping them put the slides into my deck, it's really a challenge, and they're out there really doing exciting things that you're going to hear about. So the first speaker here, or panelist, is going to be Bill Brownlow. And Mr. Brownlow is an associate professor of engineering and coordinator of the Department of Engineering and Design Technology at Montgomery County Community College. He attended the Pennsylvania State University, earning his Master's of Engineering in Engineering Science in 1991 and earned an MBA postgraduate certification in New Ventures Development in 2004. Bill's most recent publication is a paper entitled Video Conference Teaching for Applied Engineering Technology Students, which he presented at the American Society of Engineering Educators Mid-Atlantic Conference. Please welcome Bill to the stage and have him go through his speech. Bill?
Thank you.
You can just use that or
Thank
however
you.
you want to.
Good morning. How's everyone doing?
I thought how remarkable it was that here we are educators and we're sitting right amidst all of these students swirling around us. That was very, very cool. So hopefully, they'll come back. I guess they all went to class, but they'll be back. How many of you have seen the movie Robots? It's an animated movie for kids. Robots, right? In the movie, there's this robot. His name is Big Weld, and he sort of like runs a company. And he has this saying, and it's see a need, fill a need. And so in the engineering area, we try to get our students to understand that concept. I mean, eventually, engineers are problem solvers, and we want the engineering students to go out into the community and go out into the world and help them solve their problems. So see a need, fill a need. So about 15 years ago, speaking of what was going on 15 years ago, in the Department of Engineering, we constituted this concept called design of experiments, and the many of you that are educators, you give your students an assignment and you say, okay, go do this. And we turned that on its head, and we said, okay, we're going to present a concept or a theory to a student, and then we're going to say, how do you prove or disprove this? How do you get the student more involved in the process of education? There are things that I'm going to talk about in the very brief time that I have about how we get students involved in dictating or designating their own education, their own future, their own progress. And the first place it starts is with their education. So instead of giving them an assignment and saying, go do this, we give them a theory or concept, and this works for any subject, not just engineering or science. And we say, now, how do you go prove or disprove this? And we called that design of experiments. And so we were content to go along with that for about 10 years. And then we were very fortunate to have an industry specialist come in from the outside, a former chief information officer for AT&T and IBM, is a gentleman named Jean-Jacques Ramon. And he came to the department. He said, I would like to ask if you could have your students help do some research for the Swiss government. And the research was with regards to autonomous independent weather stations out in the Alps, and having quadrotors go to these weather stations and using wide area networking, communicate with them and bring the information back so that they could predict when there would be landslides. And I kind of looked at him like, never tried something like that before. What are you suggesting? And what he was suggesting is that our students would do the research. The students would suddenly go from classroom activities to real undergraduate research. And so the topic of my very brief discussion here is undergraduate research. Developing concepts, developing ideas, taking them out to the world, not just staying in the classroom, and then trying to promote to the students entrepreneurial behavior. So the first stop on our voyage, I guess, was Quad-Forge Quadrotor Research and Development, and the areas of research that we've done is remote weather station that I was describing to you, remote weather station access, and that's purely autonomous. It's wide area network related. And you're like, well, what did you have to start with? We had nothing. It's like, well, what are we going to do this with? You're going to do it with quadrotors. What are those? And then how are you going to recruit your students? So this isn't a classroom activity, and that's the whole point. We're trying to get students to see a need, fill a need, and not necessarily something that you teach in the classroom. So you have to engage the student. You have to encourage the student to get involved in class and outside of class, and design of experiments and research projects. And so in order for us to really make this thing go, we needed a research course. So we instituted EGR 291 and 292, which is Engineering Research 1 and 2, and you don't typically see that at this level. And not only do we do that here, but it's also being done at North Penn High School, so they do research in quadrotor technology. See, you could do research in middle school. You could do research in elementary school, if you were so inclined. Also, speaking of farming, right, we also do quadrotor research in the areas of mining and farming, and also real estate and emergency services, and it's all associated with this one large research program. And we said, well, what else can we do? Where are there other needs? There are needs in the energy sector, there are needs in the transportation sector, eventually we'll run out of fossil fuels, and we need to address that. So for a number of years now, we've been looking at, I'm sorry, I jumped ahead of myself here. I need to mention that last year, we were incorporated into Temple University, Penn State University, and the Air Force Academy out in Colorado, and some other institutions are all involved in a larger NASA research program. And we have a NASA research lab in our engineering spaces, which is shared with our quadrotor team, and they do nano coatings research. So they take flight instrumentation that's used on our quadrotors, and we nano coat it so that it can fly in the open. So, you know, I guess you guys would probably, if you ever dropped your cell phone into the ocean or dropped it into a body of water or something like that, you know, there goes that. Well, not anymore. There are services that'll provide that for you for your coatings for your phone, but we're coating electronics, we're coating control electronics and quadrotors so that they'll fly in the rain, and we're partnering on some research with Temple for the Navy and NASA, and it's very, very cool stuff. But what does that do for the student? That allows them to see a need, to fill a need, but in addition to that, it allows the student to get involved in higher level research, the undergraduate level. That gets them networking, that gets them internships, that gets them out in the world, and that's the kind of thing that we need to be thinking about in the classroom. It takes them outside of the classroom. So these are just some pictures of the research that's being done by the students with the nano coating for the NASA program. That's one of our prototype quadrotors, and as I mentioned to you, we design our own quadrotors, and then we build them with 3D printing technology, and we customize the control software, we customize the electronics control hardware. They build their own flight platforms. This is one of our test rigs that now Temple University is going to be adopting from us. We use it for motors prop research to find out how to optimize the best motor prop combination, and our students have been working on that for about a year now. Temple's really excited about getting that test rig. They're going to build their own. This is the research lab for the Quad Forge Research Lab and also the NASA Research Lab. And then, so as I mentioned, what are some of the other areas of need that we're trying to introduce to the students? One is energy, and one is transportation. And so in the spirit of addressing transportation needs that are looming, we decided that we wanted to build ourselves an ultralight vehicle that was hydrogen fuel cell powered, because electricity and hydrogen are the areas that will be most heavily researched going forward, especially once we run out of fossil fuels. So we designed a vehicle, and then we said, well, how can we take this out to the community? How can we get the community engaged, get more students engaged in the concerns about transportation? I don't know how you feel about it, but if I could go outside and know there's not millions and millions of cars pumping noxious gases into the atmosphere, that would be fantastic. Go out, take a big, deep breath of air and go, wow, fresh air, what's that like? So the concept is to try to get away from internal combustion engines, and we built designed for ourselves an urban concept vehicle, which we compete at the Shell Echo Marathon. This year it's going to be in Detroit again. They do this in Asia, they do it in Europe, and they also do it in the Americas. This was original prototype. Students brainstormed this idea and designed it using 3D solid modeling software. This is the actual implementation. It never quite looks like it does on the computer. And you get this, and well, okay, it's not quite the same. But it's pretty advanced, especially at the level that we're working at undergraduate level. And that's our team, or several members of our team. We take this vehicle out on the road into the community to introduce to students what you can do at this level. And then these are just some of the other areas where we saw a need and we fill a need. Students work on these projects in the Student Engineering Association. They also work on them in the research classes. They work on them in their classes. We cross-pollinate between classes so that we can achieve the most progress. And so I'll just walk through these. The Student Engineering Association was working on a prosthetic hand and identifying potential candidates, both ex-military and also people with genetic defects and injuries and what have you. And then also a wheel motor design, the idea that the motor's not in the front of the car, the motor's actually in the wheel, and it creates tremendous efficiencies that way. We also do some custom work for individuals that come to the college and say, we have a need, can you help us fill it? So that's a custom engine mount actually for a motorcycle. And then that's a pie case, so somebody may buy themselves a pie control board, and then we would design the pie case and print it out on our 3D printers. We also have lathes and mills, and we've got some tremendous stuff thanks to the Perkins organization. That's a squirrel-proof bird feeder. So we have had students in some of our engineering classes that design product, and they go out and then they try to patent it and they try to start business. We've had students start businesses. We've had students apply for patents, and it's just a tremendous, tremendous experience for us all. So again, we're trying to promote See a Need and Fill a Need. Thank you for your time.
Well, I think you can see probably the biggest deliverable there is Bill's enthusiasm towards this and how the work he's doing. It's really exciting, and I'm sure that rubs off every single day with his students. Thank you, Bill. So our next panelist is Dr. Kendall Martin. And Dr. Kendall Martin holds a PhD in systems engineering from the University of Pennsylvania and is a professor of computer science here at Montgomery County Community College. She's worked at AT&T Bell Laboratories, Texas Instruments, as well as a number of startups. Her recent sabbatical explored modern fabrication technologies and how they would be integrated into the community college curriculum. Dr. Kendall Martin, thank you.
Thank you, Brian. Good morning. So this is what happens when you ask academic people to give you 2 slides. So I have to be honest, Brian told us each to give him 2 slides, and I think we came in around 40. So it's a hazard of the business. But let me try and quickly just point out to you, my pitch today is that you are sitting in the middle of a perfect storm. Okay, there are forces that have come together at this point in time that are making the kinds of things you're seeing here possible for every one of your students. Okay, so I want you to think about that. And then background in your mind, I think we should all think about who are you? Like there are 7 billion people on the planet. How is it that you're sitting in the middle of all of this access? And of course, the Spider-Man question, what responsibility does that mean that we have to use these resources? So if we let students take control, what are they taking control of? What can we give them to work with? I would say the first thing we have happening here is revolutionary access to software and hardware. So the Raspberry Pi case that Bill just referred to, we're talking about a $35 computer. A complete Linux computer that you can buy off Amazon any day you want, $35 total, has HDMI, has internet access, unheard of, right? We're talking about having, let's see, there we go. This is our students getting their cards, getting their boxes filled with sensors and Pi boards, Arduinos, and they're faking enthusiasm for the camera. But off camera, they were very enthusiastic. So these little teeny Arduinos can come in the size, they have a form factor the size of a quarter if you want, okay? You can pick them up for $3 down at Micro Center in St. David's. So this is unprecedented, okay? This is not just how things have always been moving along. Here we have a bunch of tablets, we have software doing the same kind of unprecedented access. So App Inventor is a product that was made on a sabbatical. Google gave it back to MIT. MIT made it completely free. So you can develop Android apps with a visual drag and drop interface. We've used it with 4th graders. We've used it with 10th graders. MIT is using it with their grad students. It's not watered down. In fact, the software that makes App Inventor is free. And you can download and alter that if you want. So the access that our students have to hardware and software is something like we've never seen before. We have students posting applications into the Google App Store in our -1 programming course. So we have a 1, 2, 3 series. We made a -1 for people who just wanted to try it out. They're posting programs and apps and games into the App Store at the end of their -1 course. These are students coming in like knowing that the X closes the window, and that's about all. Come back to me. There we go. Okay, but we can take them from there to actually taking their ideas and sharing them. And that's not happened too often, okay? There's a second force fueling all of this. Revolutionary access to modern fabrication technologies. So that doesn't mean too much to me when I first started thinking about it, but this is what we're saying. There are now computer-controlled fabrication techniques, not just 3D printing, okay? 3D printing is very, very cool. There's a whole revolution in subtractive technology, all right? Taking material away and creating something. So this is a plasma cutter, all right? You put a sheet of metal underneath, you take a file from Adobe Illustrator, and this is a little pattern that I did a whole sabbatical down here, so it was hard for them to even pull me away. You know, you can make a jigsaw puzzle on Adobe Illustrator, and then you can run it through the laser cutter and have it cut the pieces out of plywood. But you can also run it through the plasma cutter and have it cut the pieces out of 1/8" steel and put the puzzle together. Okay? It used to be that, wow, these are fantastic, nice, numerically controlled machines. I'm sure they're in some distant factory somewhere far away. No, you just can go online, go to Pinocchio, and your students can take any Adobe Illustrator pattern or file they have, they can laser etch it onto any kind of material, onto leather, onto anodized aluminum, onto glass, and hit a button. And you can say, all right, I'd like to order 50 of them or 6,000. Or you can go down to any of the maker spaces showing up in the area, like Next Fab on 20th Street in Philadelphia. They have another spot on 4th and Girard. They opened another one in Wilmington because these are blowing up. This is like a gym. You pay maybe $20 a month, say, right? You get access to all kinds of a wood shop, a metal shop, a welding shop, 3D printing, laser etching, and there's somebody standing there to teach you how to use it. So we've had students say, look, you know, I'd really like to do a project. I think I'd weld, in a perfect world, like I would weld together this case, and then I'd have this Arduino control the locks on each of the drawers, and then I'd write the software so that it controlled the barcode swipe and knew when somebody borrowed one of these are systems that they sell for $25,000. So my students built one as a final project for $250 because they went down to Next Fab and did the welding themselves, right? We have all kinds of books on maker skills. That's an internet-enabled light bulb you see in the picture there. I mean, all of these things are available at an unprecedented level. So we have a course, and I have to say, this is a big faculty gamble. I know this isn't easy, but I took a week. I'm whispering because I still can't believe I did it. I took a month out of the schedule. I said, we're not going to teach that month, not in the way of me talking to you. You're going to come up with a project. I did it all, and no one knew I was doing it. Celeste encouraged me. No one else knew. But it's not, right? It's not an easy thing. You come up with a project, and then we'll see what all these groups need to learn about, and that's what we'll teach that week. And then we'll have a big presentation, and we'll show where this is the Programming 2 course. We'll show the Programming 1 students what could happen if they just stayed one more semester. All right? So we've been doing this for about 5 or 6 years now. I never would have assigned projects this hard. Never. Here's a project you can't see because the picture is from my camera, and I didn't do too good a job of it. So this team of 3 people built this frame. They found a place in King of Prussia that sells a 2-way-ish, kind of 1.5-way type of mirrored glass. And they made a smart mirror so that you walk up to it. If you see in the bottom corner there, it's displaying the time and the weather. It's displaying their Google Calendar, their Google to-dos for the day. They put a wireless button on the front, so you tap that button, and you've already run the mobile app on your phone to set it up for your needs, and it knows where you're going to work that day, and it's checked with SEPTA to see if there are any delays on the line from SEPTA, and put that up. Then you push the button again, it goes to your wireless scale. I didn't even know there was a wireless scale. It goes to your wireless scale, checks the history of how your weight's going, and puts up a really encouraging message. Right? I'll say there was a woman on this team because like that kind of caretaking only happens when women in software get together, I think. They did this in a month. It was the end of their first year of programming. Okay? I never would have assigned it. I never would have expected it. But this convergence of abilities comes from also having this third factor, revolutionary social access. So we started, my generation said, oh, you know, this is not a good thing. The students are going to talk to each other. They're going to know the answers on the exams. They're going to share homework. Oh, my God. So what it's become, it's maybe the greatest distribution and democratization of information we've seen. So this is what my students' laptops look like now. This doesn't mean that Uber sticker doesn't mean that they use Uber. It means that they spent a weekend at a hackathon with the developers from Uber, helping them use the API to make Uber better. Okay? These are not hackathons that prevent and only allow the graduate students, or there are high school students at these hackathons. Penn Apps down at University of Pennsylvania runs them twice a year. 2,000 students. There are students flying in from Englische Technische Hochschule in Switzerland to be at this. And the high school students who show up from the area, the entire place stops and gives them a standing ovation every year for being there. This is being around the 2,000 people who are going to take care of. Here it is, not the most recent one, the one before that. Comcast said, why don't you have it at the Wells Fargo Center? So we had students from Monco at the Wells Fargo Center for the weekend, and the pillowcases they gave them said, sleep, eat, code, sleep, eat. All right, so they met, everybody from Google comes in, there's our student Sufi Benor, and that's what he looked like on Friday, and this is what he looked like on Sunday. So it's not easy, maybe, but they take breaks and get donuts, they go, I mean, it's a social event as well as an enormous programming event that exposes you to ideas that people have not seen before. This is from the event we have where our pre-programming students come see our programming students' projects. A lot of my students' projects, they're not starting with a blank page. There are sites like GitHub where everybody is sharing their code. If you can make it better, make it better. The code for the drone that Bill talked about is from Brazil. Okay, and we had students who took down the code, said, you know what, this is a bad way to do this, let me make it better. And then reposted it, and it's now being distributed internationally. So we have students who say, you know what, I would love to, one of our students said, you know what, I would love to have, there are a lot of Korean places in Lansdale, right? There's a lot of Korean language on the signs in Lansdale. Wouldn't it be really awesome if, depending on which way was easier for you, you could hold up your phone and the Korean would start showing up in English, or you could hold up your phone and the English would show up in Korean. All right? So this is Rob, who's right in the front row, who's embarrassed right now, maybe. So what do? That's a hard project when you've only been programming for a year. Unless you go onto the web and you can get the master's dissertation from somebody at the University of San Francisco who's been thinking about this, start with that code, and then make it better. And that's what he did with his team. I have no problem with that. Cheating? Like, you cheat all day, if that's how you're gonna cheat. If you're gonna figure out master's level code from somebody else, and then be able to improve it and distribute it around, you see, what we know now is that students get motivated. There's a really clear understanding of human motivation at this point, right? Daniel Pink's book, Drive, talks about this. People get motivated by three things. Autonomy. You're not very motivated when somebody else is telling you what to do every bit of the day. And you know that. We all know that, right? autonomy, mastery, you've got to be able to see yourself getting better, or you lose interest. There's got to be some measure of performance that you can watch yourself get better at, okay? And then purpose. If you don't have those three things, if you don't feel that the work you're doing is helping someone, that it matters, if you don't feel in charge of the work you're doing, if you can't see that you're getting better at it, you're going to be dragging people to the finish line, okay? But if you can find a way to put those three things into the way you conduct work with students, you're standing at the center of a perfect storm of support and resources for you, and your students will do things that amaze you. Thank you very much.
Passion. So just to tie this together for 1 second, and then we're going to take your questions, is these are, you know, what scares me as being a vendor out there building systems for higher education is these are the students that are going to come in, because inevitably people will work in institutions after they've done all this stuff. So why I get up in the morning every day is to figure out how can I get these transaction systems, this stuff that Celeste and I work on, to the level, if you will, of how these students are being educated. And I've seen it firsthand. We have an intern that we brought into the research group, and he worked in his sophomore, junior, and then we hired him right after he graduated. And he's already accelerated to the point where he's doing the same work as someone that has 10 years of advanced technology experience in industry. So it's working from end to end, and I feel a responsibility for continuing along with the process that Kendall and Bill are doing, so that this kind of goes full circle. I believe that these folks that are working in my industry, higher education, will demand a lot more, quite frankly, than what we have today. So with that, I think what we wanted to do is take about the last 10, we have about 10 or 15 minutes left, I believe, correct? 9:45. 9:40? Okay, so 5-10 minutes, okay. So we'd love to have your questions, comments, encouragements. We're off on this questions, so who wants to go first? Are we on the right track? Yes, sir. Yes, so the question is, as a person that leads these systems that we're building at Ellucian, where does privacy stand on all this? And I'll tell you, that is really a concern. I think that we're really working with how exactly do we make this. I mean, most of what you see in social systems, and a good example is Waze, is that you can just opt out. In Waze, you can go invisible. So I think fundamentally what I've believed about security is the first thing is that everything that you want to do with security should be in the end user's hand, right? And I learned that a long time ago. So you should be able to say, I don't want my data to go anywhere. And we're not there yet, but I'm just talking about sort of from an advanced research perspective is the person that is using the solution, in any case, in any sort of perspective, should be able to control their security, where their data goes. And then there's a pretty stringent law in Europe, I can't think of the exact title of the law, that really talks about things like your right to have all your data removed, your right to ask the company for your data, exactly what do you have. And so since we build systems worldwide, we are really working with that, as many other companies are as well. So those are kind of the guidelines, is how much can we push to an individual so that an individual can control their own security, and then how can we make this information available if you want, and how, and sort of the guidelines of that European law. It's a good question, and it's something that's now at the forefront of the discussion. Security used to be something we added at the end of the development cycle. It's now something that gets built into the design cycle. Yes, sir.
Hi, my question is still kind of forming itself in my head, so
Okay.
bear with me for a
Yep.
second. I sense a potential conflict or tension, if you will, between the kind of data-driven curriculum planning, assessment, etc., as opposed to the very creative and forward-thinking curriculum development being done by people like my colleagues here.
Mm-hmm.
And the pressure from certain areas to create things that are sort of in the can, accessible, quantifiable,
Right.
as opposed to these open-ended, create it sort of curriculum, wonderful directions. I'd love to hear
No.
comments on just
Celeste?
my discomfort level or my apprehension, shall we say,
Yeah.
with that.
So I'll respond first, and then because I work with these two folks pretty closely, would love to hear if they think that I'm on track or not. So I do not see data and analytics as quite in the box that you just put it. I think that's the box we used to be in. I call it the rows and column box. So imagine Excel spreadsheets. We're beyond Excel spreadsheets. That's not the kind of assessment we're doing today. And I've got my new executive director for IR here. That's not what we're doing anymore. We want to see this kind of engagement, and this is what happens. We don't start, so let me separate. There's two kinds of, there's reporting, mandated, federally mandated, state mandated. We do those things. But from an academic perspective, from a student perspective, the assessment components are really much more than row and column data. So what we do, Kendall I've done this more with than anybody else, what we do is we sit down, we talk about how do we engage students. That was sort of my little tiny piece that I talked about earlier. How do we engage students? The faculty, what we want is to come up with the creative ways to keep students engaged. When we hear that from a research perspective, we'll come up and work with the faculty on how can I measure that. But measurement is not yes, no, follow the check boxes. It really is bigger than that, and there's lots of ways to measure. By the way, hard to do, you're right, but right now in the world of analytics, learning and measuring learning is really, you are going to see much more occur in that arena. We've measured services for years. Now we're going to try to work on measuring learning, and the way that they are participating in that endeavor with their students is not an easy task, but it's doable.
So let me just jump in quickly, Andrew, because it's an awesome question. It's right at the heart of my fear around AP, for example. Okay? So like my daughter went to a portfolio graduation school instead of an AP school, and I was really happy with the results from that. So the way I get those students to be able to do those projects is that in the first half of that course, we use an automated tool that gives them uncountable attempts at very small little problems and feeds me back a dashboard that shows me exactly how many students got each question right and wrong, and I come in and I target exactly that topic in the lecture and then send them out. The first time I used this software, I called the company. I said, how many times are my students using it? They went and they looked. They said they've done 9,000 problems. I said, no, you got to be wrong. Like, there's only 30 of them. They couldn't have. No, they said they've been using it nonstop. They've done thousands of problems. So they get so much feedback, as if I was standing by their shoulder almost, you know? I really couldn't have the time to do that for every one of them. So I kind of split it, right? I used that kind of analytics to really target and get them to the skill level where I can then say to them, go be creative. Because without the combination, they would have great ideas, but they couldn't execute.
We have a prototype that we're working on, because I know Celeste mentioned our work in virtual reality, where you're looking at a diseased heart and you're identifying through the Google Cardboard, you're identifying what type of disease the heart has, and this is flowing back through QTI, which is a quiz standard. So we're trying to catch up a little bit with some of the work that's being done here, and so that our learning management can still do the assessment even though it's being done in virtual reality, using that technology. And so when they're working with the things they're kind of working at, assessment doesn't stop. We have to come up with technology that's going to allow that assessment to occur over and above what they're talking about, that assessment to occur with the teaching technologies that they're using.
And I want to support or back up some of what Kendall was talking about. I remember going through the whole assessment development process for engineering, and design of experiments is a keystone for us. And the assessment committee was actually very impressed by that. We were trying to find ways of engaging students in the learning process. We're trying to verify that what we're telling them they understand. So the key to us was, how do we get the student to want to engage in the process? We just hand them something, we say, go do this, wasn't working. So we turned around and we said, okay, we're still going to teach you. We're going to teach you the basic concepts and principles, but you have to turn around and then tell us why it works. And that turned that whole process on its head. And we could still then assess what they were learning, because they were handing us this information and saying, this is what we understand. And that was so much more valuable than just telling them what to do and having them go do it.
Okay, I think we have time. Can we do one more quick question and then we'll wrap? Okay, does anyone have any?
I have a quick yes or no question. This is for Bill and Kendall. With the challenges that you've given your students, and some of them doing upper level classwork, have they been able to attain credits of junior or senior year in a four-year college with any of the work they've done?
You know, the experiences I've had, for example, with like really successful students in my classes, we've had students who've transferred on to Bucknell, and so emailed me back and said, I just showed the portfolio that I have to my Bucknell professor. He said, this is what they do in their senior year. So it's not that they're getting credits outside of the credits they receive for the coursework, but they walk away with a portfolio, and that portfolio is opening doors for them.
And for our students, so we have the engineering research 1 and 2 class, and of course they get credit for that, which they can transfer on. But more importantly, they have that same portfolio experience. It leads to internships, it leads to jobs in some cases straight out of the college here, and it also leads to them getting research assistant opportunities. It creates a tremendous amount of visibility for them, but more importantly, it shows the transfer institution the kind of qualities, and knowledge, and experience that they have that they otherwise would not have.
Okay, I think we're out of time, but listen, I really want to thank all of you for attending. I want to thank my esteemed panel here. They did a wonderful job, and thank you all, and I want you to enjoy your conference today and all the additional sessions. Would you like to come up? Yep.
Thank you, Brian, in the session panel. Real quickly, we realized that one of our vendors was not represented on the sheet. Veronis is actually doing a presentation in room 224 at 11:55, so please consider going to that. For the sake of time, we are going to skip a video that we were going to show of students talking about their educational environment, but we will provide that to you so you can watch. If you could go to the second floor in ATC, there is a poster asking us, what are we going to do to help our students? Please put your ideas on that board. The rest of the conference is going to be moving over to ATC. There are going to be people directing you to that building. Please go and follow kind of the masses to that building and enjoy the rest of the conference. Don't forget to do your conference evals. Thank you.